Okay, so we're going to solve a problem that a couple of students asked about finding area between two curves. So this one is actually between two curves and then two vertical lines. The lines x equals -5 and the line x equals 2. So first of all, we need to have a clear idea of the picture of this to solve this problem. You can't solve it if you don't have a clear idea what the situation looks like. So let's go ahead and sketch. It doesn't have to be a perfect graph, but let's have an idea of what this situation is happening here. So the parabola x squared minus 12 is a upward parabola with centered, or symmetric around about the y-axis and vertex at -12, right? So it's down here. I'm going to try to draw something just like that. So this is the parabola, the red parabola, and this is at -12, right? Okay. The green line, y equals -x, is just a line with slope 11. So I'm not going to be very careful. I'm going to draw something. It looks something like that. Okay, so the line, oops, sorry, let me try to make it go to the origin. Something like that, right? It's a line that goes to the origin, y equals mx, the slope is 11. So these two curves or a line and a parabola intersect at 2 points. So let's try to find those points. Let me try to work out where these two curves intersect. So one of them is right here for the parabola and the line, and the other one would be over here, right? So how do we find where those two things intersect? Well, they intersect at the points, at the point. So I need to do, set them equal to each other to find where does the parabola x squared minus 12 intersect the line 11x. So you put them equal to each other, and this becomes, when you want to solve it as a quadratic, you get this. And you can do an equation, but of course you can also just factor. This is x minus 12 and x plus 1, I believe, right? So this means that they intersect at x equals 12 or x equals -1. Okay, so this is the one that interests us because this is going to be at -1 right here. Okay, the other one, x equals 12, is over here, but that's not going to interest. We're not going to care about that one because if you look at it over here, at least it's the area between those curves and also between x equals -5 and x equals 2. So I'm not going to go all the way to 12. I'm going to start up at 2, wherever that is. Somewhere around here is the only place we're going to integrate. Okay, so here's at 2. And at -5, which this is -1, so I'm pretty sure -5 is going to be somewhere over here. Okay, so these look something like this. So the area that this is talking about, the area between the curves, is something like this. Let me see if I can shade this. Let me try to make this, I don't know, orange. So between x equals -5, it's this part. That's the area between the two ones. And then after 1, they cross, and the green is above, and it's this area, only up to 2. Okay, so that's the area I'm looking for. This one between -5 and -1, and then this one between -1 and positive x equals 2. So the integral I need to solve to find this area, there are two integrals. Now for this part, I need to do, it's the integral from -5 to -1 of the red parabola, because that's the one that's on top. Okay, so you're going to do x squared minus 12 minus the green line. Okay, that's the one that's in the bottom. So that's how you find the area for this part. Okay, I have to put a dx right here. Let me put my dx right here. And then I'm going to add the integral for the second part, which is this one. That is between -1 and positive 2. And now the green line's on top. So now I do 11x minus the red parabola. Don't forget these parentheses, x squared minus 12. Dx. So this is the integral I need to be doing. There's two integrals. And the first one, basically the big idea is you're always going to find the area between two curves as one function minus the other function, but it matters which one is on top. Okay, so if the two curves intersect, you need to find where they intersect, in this case at this point, because before you intersect, the red one is above, so you do red minus green, and after that point you do green minus red, so this one. So yeah, I mean, it's not hard. The integrals are pretty much the same, just one of them is a negative of the other. So if you work this out, this becomes negative 5 to negative 1 of x squared minus 11x minus 12. And this is integral from negative 1 to 2. It's negative x squared plus 11x plus 12 dx. So the integrals are the same, just one of them is negative of the other. You can't combine it because the limits of the integration are different. So you do have to do this one first. You have to do x cubed over 3 minus 11x squared over 2 minus 12x. And this guy evaluated between negative 5 and negative 1. And then negative x cubed over 3 plus 11x squared over 2 plus 12x, and this guy evaluated from negative 1, from negative 1 to positive 2. Okay, so you put these numbers in, now it's just about evaluating, and this would give you the right answer. So I'm not going to do that, it's just a matter of putting in the numbers, and be careful. Okay, so the big idea is this. In problems like this, you don't need to have a clear idea of what the picture looks like, and if not, you can't solve it. Right? You need to know from where the negative 5 and the 2 are important, and then you have to know in these intervals what is the region that you're integrating, and which are the two curves on top and which is in the bottom. Okay, I hope that helps to clarify this one, these type of problems.